Hey everybody, in this lab video we're going to use our Hot Wheels track and Hot Wheels car to send the car flying off the edge of the table and see where it impacts the ground. We're going to use the information about the range of this projectile, how far it travels horizontally away from the table, as well as information about the height of the table to work backwards and figure out how fast the car left the edge of the table, its horizontal velocity. This is leaving the table at a horizontal on a horizontal table, so it's a horizontally launched projectile. Take a look at the lab setup real quick for those of you who are playing the home game, so to speak, and you're not able to come into class to do this one. We have our Hot Wheels track set up here, coming right to the edge of the table. We like to leave a little space there to ensure that the car leaves horizontally. I'm going to release the car. I'll do just 3 trials. I'm going to release the car from the same spot right here, and something that I can do to make sure I don't forget where I'm releasing the car from is I can put a little mark in Expo. Okay, and I'm going to release the front of the car from that position each time. Right here, it's going to come down the track, swoop, fly by, boom, and hit somewhere on the floor. We'll have it in slow motion the moment, or for the fraction of a second where we get to see it impact. And we'll have the camera positioned up top so we can see where it landed. This is the end of the first meter stick where this tape is. It's not going to go more than a meter. So my extra meter stick is kind of useless right here. The only distance you need to care about for the horizontal distance that it travels is going to be given by this first meter stick, which you can see, starts at the base of the table and goes along this length here away from the table. Okay, so that's how we will get our range or distance traveled by our car. We'll do 3 trials. Then we've got the height of our table. Sorry about the shaky camera. This may not be exactly the same as the previous height measurement because it is a different table. Okay, and this meter stick goes all the way down to the ground. 0 line is on the ground. Okay, so I'm going to do 3 trials. I'm going to release the car from rest from that position on the track that I marked. It's going to accelerate and leave the table with some horizontal speed or some horizontal velocity. That's what you're trying to figure out. You got a height measurement, and we're going to look at 3 trials for the for the range, for the distance measurement. You can take the average of those or figure out the speed from each of those trials and then get an average if you like, whatever. So let's position our camera and get ready to roll. Camera's going to point straight down. I know kind of the area of where this thing's going to land, so I'm just going to kind of set us up there. I don't want to get in too close, but I do want it to be close enough that you can actually read measurement. That glare is kind of annoying. I think this should be an okay spot. Okay, let's get ready for our first trial. If it doesn't land in view of the camera, then we'll just call that not our first trial. Okay, here's the first one. 3, 2, 1, go! I think that got it. Kind of hard to see without it in slow motion yet. 3, 2, 1. Go. Okay, I think that also got it. Maybe if I can just give us a little more. All right, here's trial number 3. It's like a flash, and then it's gone. All right, and in case you couldn't see the first 2 I did, I'm just going to do a couple more. Make sure we can So it seems like it's landing in this pretty much the same spot every time. Pretty consistent, I guess. Okay, so that's it for our trials. Something I didn't mention is that what we're doing here is taping the end of this down so it doesn't wobble around, and that helps us with the consistency. We'll come back in later labs to using a similar setup for Hot Wheel cars and tracks, because you can do a lot with them. Autofocus. Okay, that's it for this lab. Yeah, that's 4.2. Predicting speed by working backwards from knowing the range.